we can never ever do enough trig because it's such a big section in paper 2, often something that we struggle with. So I wanted to come back and revise some trig with you. Tonight we're doing what we would refer to as our basic trig, but I mean, that doesn't mean that it's easy. And then I'll do some more advanced sort of questions with you in our next paper 2 session, which will be next Thursday. I've also got some problem solving questions that I want us to cover tonight. So I hope you guys have got your thinking caps on. All right, we're going to get started with question 5. Yes, so what I'm going to do is I'm going to finish off just 2 minutes early, and then I will go back. I know about that question. It's this one over here, 10.4. Okay, so I promise you I haven't forgotten about that. I will finish that particular question with you. It looks as though she's done some working here and she's got the answer, but maybe she just didn't finish explaining it to you. Okay, so yeah, promise I haven't forgotten about it. We will do that. Okay. Okie dokes. So let's get started on question number 1. They've given us, given that cos theta equals -2 over root 13, where theta is an angle between 180 and 360, determine the value of the following without the use of a calculator. All right, so let's start there. Just to get ourselves into the swing of things. Okay, so what is the first thing that we need to do here in order to answer question 5.1.1? What would you guys do? You're right. This is a question using a co-ratio. You're quite right, Linda. Absolutely. So you know in 5.1.1, you know that sine 90 minus theta is equal to what, Linda? Cos theta, exactly. All right, so Lethal, you're saying drawing a triangle in the cos diagram. We may need to do that for the second part, absolutely. So for this first part, we would simply do this. We would use our co-functions and we would get cos theta. So we know that this is also going to be equal to -2 over the square root of 13. Okay, yes, so we can begin by drawing a triangle, but we don't need our triangle for this question just yet. Okay, it's only out of 2. All right, let's go and have a look at the next question. Now here they want cos 2 theta. So what would we do here? Maybe I should just go up a little bit and then you can have a look at your formulae. What would you do now? Double angle, good, Linda, absolutely. Linda, does it matter which one we use? Does it matter which cosine double angle we use for question 5.1.2? Correct, Kamogelo, it does not matter. So when we are doing Pythagoras, like these sorts of questions, yeah, but some are quicker, quite right, Linda. So I think in this case, because they've given us cos over here, probably better for us to write cos 2 theta as 2 cos squared theta minus 1 in this particular case. All right, now what are we going to do? We have to sub in. Okay, so we would put in our 2, then we would put in our -2 over root 13, and we would need to square that, and we would need to take away 1. Okay, and then we've now got our 2 on the outside. This would now become positive. Whoopsie daisy. That would be 4. This would be 13, and then we would have to subtract 1. So that gives us 8 over 13 minus 1. So that would be 8 over 13 minus 13 over 13. So that would give us negative 5 over 13 as our final answer. Okay, so that was out of 3 marks. Always a mark for using a compound angle formula or a double angle formula or an identity from grade 11. Another mark for subbing in, and then the last mark on our answer. So in some cases, when we do questions like this, we do need to draw a diagram. And then obviously do the theorem of Pythagoras. But in this particular case, that actually was not necessary, but often you do have to do that. Okay. What I'm going to do now is I want to sort of jump to the questions that are a little bit more difficult. We've got our brains warmed up, hopefully. So what I'm going to do is I'm going to leave out question 5.2 because it's actually very simple. It's just a compound angle formula. All right, so you would just write the reduction of that and then work out the answer. If you guys, maybe I should let you guys do that very quickly instead of leaving it out. Should we do that? Should we just do it very quickly instead of leaving it out? So compound angles. Oh, there is a little bit of a twist in the tail here because you've got sine 27, sine 33. So there would be something that we would need to do here. Can anybody tell me what that would be actually? What would we do in 5.2? The first thing that we would do. So Linda, before we do the compound angles, we don't have a compound angle that begins with sine. So our cosine compound angles begin with cos, and they end with sine. So if you have a look up at the top here at our cos compound angles, you can see it's the same. It's cos first and sine next. There we go. Good job, Linda. So you can go ahead and do that and get done. What would the rest of us do? How would we get this so that it's in the correct form? We would need to factorize. So we would end up with cos 27, cos 33. Remember, we've taken out a minus. So this would become a minus. And then we would have sine 27, cos 33. Whoopsie, let's just move that over just a little bit. I'll just write that second part a bit nicer. Okay, so we can't forget about this negative in the front. Okay, so now if we go and have a look at our compound angle formulae, where we've got the minus in the middle, that would be where we've got to plus the angles together. Okay, so this is going to be equal to negative, and here we're going to say cos 27 plus 33. And if we add 27 and 33 together, we're going to end up with what? 60. So this is negative cos 60. And the cos of 60 is a half. So this is negative 1 over 2. Okay, quick and easy, hopefully. So definitely a mark for taking out the negative, a mark on the minus cos 60, and a mark on the negative half. All right, let's jump into some more difficult questions now. Let's look at 5.3. They want us to show that the left-hand side equals the right-hand side. So let's get started on that particular question. Okay, so I'm going to write down the left-hand side first of all. And you guys can do the same. So they've given us the cos of 90 minus x times cos y minus cos 180 minus x times sine negative y. And all of this is over cos x times cos y minus 360 minus sine 540 plus x times sine y. So a lot going on there in that left-hand side, and we want it to equal tan x minus y. All right, so there's just our formulae. We'll pop them over to one side. Okay, so what is cos 90 minus x equal to? Good, sine x, lovely. All right, so that's equal to sine x. We can do nothing with the cos y, so we'll just leave it as it is. Cos 180 minus x, what's that going to reduce to? What's cos 180 minus x equal to? Yes, indeed. So that would be equal to negative cos x. So I'm just going to put that in brackets. Okay. And sine negative y would be equal to sine negative y. What would that be equal to? So when we see the minus y, we know that we are in quadrant 4. Good, Linda. So that would be minus sine y, like so. Good, Offense. Yes. Perfect. Well done. Very good. Okay, so we've done some reduction up at the top. Let's go down to the bottom now. So there's nothing we can do with cos x. What would happen to cos y minus 360? What would that give us? Good, Camujelo. That would give us cos y. So we could add 360, or we could go and work on the Cartesian plane, but that's perfect. It would give us cos y minus, now sine 540 plus x. What would we do there? Okay, so you're both saying that it would become sine x, but just be careful because it's going to be negative sine x. Does that make sense to you? All right, so I've got my minus written down. If I look at the sine of 540 plus x, I could take 360 away, right? So that would give us the sine of 180 plus x. So that's going to become negative sine x because I'm in quadrant 3. So again, here I'm going to use brackets and I'm going to put minus sine x in the brackets. And now I've got sine y. Okay, is everybody cool with where I've got to so far? Are we happy? So if you're all happy, let's just tidy up our signs and then we can see where we're going to go from there. All right, so we've got sine x cos y. A negative times a negative is a positive, but times a negative would be a negative again. So that would be minus cos x sine y. And we're going to do the same thing in the numerator. We're just going to tidy things up a bit. We've got cos x cos y, and here it would be plus sine x sine y. So what do we think we're dealing with now in both numerator and denominator? What are they wanting us to work with? What do we have in numerator and denominator? Exactly. Okay, good, Linda. Good, Mosey. We've got our compound angles. All right, so they've given us our compound angles, but they've expanded them. Okay, so I'm just putting that over there just so that it's out of the way. Right, we've got the expansions. Right, so what I'm going to do is instead of writing underneath, because then it's difficult for you guys to take screenshots and whatever, not that you would ever do that in your exam, but I'm just doing it because we're on the screen at the moment. You would continue to write underneath. What can we do to the numerator? How would we rewrite the numerator using the reversal of our expansion of our compound angles? Good, Jude. Good, Linda. Lovely. Both of you are correct. So we would write that as sine x minus y. Beautiful. Well done. Okay, so remember Kamogelo, yes, as a sign identity. Good, Lichlu. Kamogelo, remember sine keeps its sign. So sine keeps its sign. Okay, so if there's a minus here, there's going to be a minus over there as well. Okay, good. And now down at the bottom, we've got cos, and then sine. So that is a cos compound angle. Remember, cos doesn't keep its sign. Good, Avio. Good, Offense. Lovely. That gives us the cos of x minus y. Okay, and that would be the second to last step, because now using our tan identity, we could write that as the tan of x minus y. All right, well done, everybody. So, whoopsie daisy. Let me just put it back there. That means we've answered this question successfully. Okay, so that was out of 5 marks. And they give us questions like this really because these are the sorts of things that they expect us to know very well in matric, especially our reduction formulae. Okay, so there would definitely be, I'm going to work backwards. There was going to be a mark on sine x minus y over cos x minus y. That's obviously not a mark on the answer. Then I think they would have to have marks on numerator and denominator here as well. Sure, Linda, I'll explain that now, not a problem. And then my guess as well is that there would probably be a mark. Oh, it was out of 5, wasn't it? Sure, only out of 5. 1, 2, 3. Okay, so numerator, denominator 1, 2, 3, 4, 5. So that's what I would think they would put the marks in this particular case. So on accuracy on the numerator, accuracy on the denominator, then accuracy on your simplifying, and then on your sine x minus y over cos x minus y. Okay, so Linda, you just wanted me to explain something very quickly. That was cos y minus 360. So if you've got cos y minus 360, the easiest thing for you to do here, Linda, is just to add 360. What happens when you add 360? You're in the same quadrant. So that's why you'd end up with cos y. Okay, the other way that you can think about it, well, there's 2 other ways you can think about it, but the other way that you can think about it is that if you go y degrees that way, and then you do minus 360. Minus 360 is changing direction and going 360 degrees in the opposite direction. So you'll still end up in quadrant 1 where it would be positive. Okay, does that make sense? But probably the easiest thing to do is just add 360. Okay. All right, cool. No problem. Now let's move that down. Okay, and let's go and have a look at what else we've got here. I really can't wait to get to question 5.5. I'm quite excited about doing that one with you. Let's do 5.4 before we get there. Okie dokes. So in this question, they say to us, if tan of 42 is 1 over m, express the following in terms of m. So this is a ratio in terms of a letter. So if tan 42 is 1 over m, express the following in terms of m. So the first thing that they give us is the cos of 222. So how could we make 222 using a reduction formula and our angle of 42? Absolutely. Okay. So we're going to run into a problem, and I use the word problem in inverted commas here because it's not a real problem, but yes, absolutely. So, and I'm just making little notes on the side here. This is not part of my formal answer, but you're quite right. The cos of 222 is the cos of 180 plus 42, isn't it? All right. So that would then reduce to negative cos 42. But we don't have the cos of 42. We've got the tan of 42. So what are we going to have to do in this case? We're going to have to work in a triangle, or we're going to have to use the theorem of Pythagoras. Oh, excuse me. Sorry, guys. Okay, so let that be the first thing that we do. I think what I'm going to do here is I'm just going to rub this out, and then we can use the space over here in order to write. We can leave that over there. Okay, so let's use a different color. Okay, so in 5.4.1, if we draw a right-angled triangle, okay, and they give us the tan of an angle, we have to label that angle as 42 degrees. Remember, the tan of any angle is y over x. So they are telling us with the ratio over here that y is equal to 1 and x is equal to m. So at the end over here, our coordinates are m and 1. What's missing is r. So we're going to do the theorem of Pythagoras. So we're going to say m squared plus 1 squared equals r squared. So that means that r is going to be equal to m squared plus 1. And we know we have to take the square root of that. And obviously we'd be working with the positive r value because r is the length of the terminal arm. So we need that to write cos theta. Okay, because cos theta is x over r. So as far as the rest of our solution for this question is concerned, let's just get rid of that question as well. Now we can go ahead and say that the cos of 220 degrees is equal to negative cos 42, and that's x over r. So that would be negative m over root m squared plus 1. Is everybody happy with that? So a mark on the minus cos 42, a mark on the answer, and then on using our identity. Okay. All right. Okay, so the next question, I'm just going to scooch over here. Oh, sorry, that was a remnant from where we were writing earlier. Now we want to do 5.4.2. So the sine of 84. So what do you think we're doing here? The sine of 84. Exactly, that's a double angle. Quite right. That's it. It certainly is. Okay, so the sine of 84. So I'm just going to write that down over here for us. It's the sine of 84. And we know that that is the sine of 2 times. Let's just see if we can, oh, we can't scooch over anymore. Let's just do this, and then it'll give us a bit more space on the side. So that is 2 times 42. And remember, our angle is in terms of 42. We just go back. Remember, we had the tan of 42 equals 1 over m. So we want to work in terms of 42. So now when we write that, we would get 2 sine 42 cos 42. Okay, and now we could replace the sine of 42 with its value in terms of m. So remember, the sine of any angle is y over r. Okay, so this would be multiplied by 1 over root m squared plus 1 multiplied by the cos of 42, and that would be m over. Sorry, I need to scooch over even more. Okay, remember, the cos of any angle is x over r. So this would be m at the top, and at the bottom we'd end up with root m squared plus 1. Okay, and there's a little bit of simplification that we can do here. So remember, when we multiply fractions, we multiply numerators and we multiply denominators. So this would end up being 2m at the top, 2 times 1 times m, and root m squared plus 1 times root m squared plus 1 would give us m squared plus 1. Okay, so as far as this question is concerned, Matrix, writing it as a double angle, subbing in, and there on our answer. All right, is everybody happy with 5.4.2? Are we all good? Are we feeling strong like a lion, I hope? Okay. Good, Avayo. Good, Shisana. Okay. Kamachelo, what I'm going to do, Yolanda, will you just assist Kamachelo, please? I think Kamachelo is just struggling to understand this one. Is that okay, Yolanda?
Yes, yes.
All right. So Kamachelo, Yolanda's going to assist you. And if you've got any questions, I can certainly come back to that at the end. All right. Okay. I want us to now have a look at the next question, 5.5. And don't worry, Kamachelo. I'm going to give you a bit of time to understand this one as well. So I'm going to rub this particular question out so that we've got space to write here as well. So read question 5.5 while I rub this out. And we're going to talk about it now. So if sine theta equals cos theta plus p, and sine theta equals minus cos theta plus q, determine the value of cos 2 theta in terms of p and q. So this is a problem-solving sort of question. They want us to do something with this to get cos 2 theta. All right, so I'm going to give you a minute to think about it, and then you can make some suggestions if you'd like. Well, I'd like you to make some suggestions as to where you think we would start with something like this. I'm writing back to you, Linda. So that's interesting. Pumi and Vi, you saying the same thing. Oh, Mosey, you saying the same thing as well. Oh, I can understand why you would think that. Sihawu.
Jolie, is it possible to just scroll a little bit up? Sorry, just want to recheck. Yes, thank you.
No problem. All right. So I understand why you say that. Okay, so Pumi, Sihawu, just 1 second. Pumi, Mozi, Avayo, and Linda. Okay, I understand why you guys are cool and try and redo it. I understand why you would think that because they're both equal to sine theta, so therefore they must be equal to one another, right? But remember, if you have a look at the rest of it, it says determine the value of cos 2 theta in terms of P and Q. All right, so somehow we have to use cos 2 theta and work with our P and our Q. So in this particular case, equating them to each other is not going to help you to solve this particular problem. So in terms of P and Q means that we want P's and Q's in our answer, don't we? Okay. So no, that's not possible in this case, Jude. So if they want it in terms of P and Q, then perhaps we should make P or Q the subject of the formula. So if I use the first equation and I made P the subject of the formula, what would P be equal to? So working with this first equation, what would P be equal to? Aha. So it would be equal to sine theta minus cos theta. Good, well done. Okay, so remember when you take the cos theta over to the other side, it's got to change its sign. All right, and let's do the same thing with the other equation. Let's make Q the subject of the formula. What would Q be equal to? Okay, good. Yes. So that would be equal to sine theta plus cos theta. Now think very carefully. All right. Look at your formula sheet and look at the things that cos 2 theta is equal to. It's equal to cos squared theta minus sine squared theta, or 1 minus 2 sine squared theta, or 2 cos squared theta minus 1. So we want to get one of those things on the right-hand side. Either one of those three. Which one of the three do you think we're trying to get from P and Q? You're very close, Linda. Very, very, very close. You've just forgotten one tiny little thing, but I won't tell you what that is just yet. Jude, I'm sorry, you've left something out, and there's the sign is correct, but P is not squared. All right, but that's very good. Well done. We're going to see the solution now. What would happen if you multiplied these two things together, guys? What would you get? There you go, Linda. Good, well done. Okay. So maybe Linda, you're happy to share that with us. I would love to know what your thinking on this was. But can you see that if you multiply P and Q together, you get difference of two squares? Can the rest of you see that? So in other words, PQ would be equal to sine theta minus cos theta multiplied by sine theta plus cos theta, which if you did FOIL, you'd end up with sine squared theta minus cos squared theta. Now, that is almost identical to your identity, but the order's wrong. So if we wanted to change the sign, so in other words, what we could then do is we could take out a negative. All right, so in other words, if we had sine squared theta minus cos squared theta, we could rewrite that by taking out the negative. That would give us cos squared theta minus sine squared theta, wouldn't it? Does that make sense to everybody? All right. Or I suppose the other way that I could look at it if I wanted to over here, all right, is that, let me bring my PQ down. If I take this side and I multiply it by -1, I can take that side and I can multiply it by -1. Then I've done the same thing to both sides of my equation. So now I've got negative PQ is equal to cos squared theta minus sine squared theta. And that would be equal to cos 2 theta. Okay, so cos 2 theta is negative PQ. Isn't that a clever question? Okay, well done, Linda. You got that right. How do the rest of you feel?
Ma'am, could you please scroll back up just to do
Yeah,
screenshots?
just to get it. Yes, with pleasure. There you go. So there's the question. Sure, Velotion. All right, nice, clever question for us. Okay, Velotion, I hope you've got what you needed. And now we can move on and go and have a look at some of the other questions that I've got lined up for us this evening. Okay. So if you want to, you can always take a screenshot of this and then come and try these questions. That's not a problem. What I want us to focus on now, just in the time that we have left, I actually want to go to question 5.5. And I want to do that first. And if we can squeeze in question 5.3, then I'd like to do that next. So I want to do this general solution with you. So recall, we do a general solution when they tell us to, or if they tell us to solve outside of 0 to 360, we have to do a general solution. Or if the angle given and the angle that they're asking us to solve for is not the same, then we've got to do a general solution. So in this case, they told us to. All right, so we've got sine 2x, and it's equal to cos 2x minus 1. So perhaps I should grab our there we go. Let's put that over there and just have that on hand. And now we can do this question. All right, so what do you think we should do in this case? We know we're doing a general solution. We've got our double angle formulae here in front of us. So what would you guys do? What would you do here? Okay, so Shoshana says bring everything over to the left-hand side. Okay, so you want to collect everything together. Eventually, I think I would do that, Shoshana, because we're expecting that it's probably going to end up being quadratic, right, at some point. So we will have to do that. But before we get started on that, mind you, I suppose it doesn't matter whether you do it in the beginning or not. So that's not wrong, all right? I would rather use my double angle identities, absolutely. So I'm going to rewrite sine 2x as 2 sine x cos x. Now on the right-hand side, I've got cos 2x. How am I going to know what to change it to? Okay, so Trish has made a suggestion. Trish says change it to 1 minus 2 sine squared x. Is there any particular reason why you chose that one, Trish? Is there any particular reason why you chose that one? So we have the same trig ratio. Okay. Sure. Okay. So there's nothing wrong. There's nothing wrong with this. So what you've done here, Trish, is that you've chosen one of them that's going to cancel out the one. Okay. Exactly, Pumi. There we go. So we've eliminated the one. So I think that's a good idea, is to eliminate the one. Of course, the other option here is to write the one as sine squared theta plus cos squared theta. I don't know, I suppose we could try that, but I'm happy with this. Now we're going to do what Shoshana said. Yeah, so theoretically we could Kamachelo, but this will be a little bit simpler, but yes, we could. And now we're going to do what Shoshana said, and we're going to move that 2 sine squared theta, or x, sorry, over to the other side. Remember, on the right-hand side, we've now got 0. Minus 2 sine x cos x, and this will be equal to 0. Now, what do we want to do? So we've got them all on the same side in order to do what, guys? Take out a factor. Oh, yes, you're quite right. That should be a plus. Who spotted that? Avio, well done. Thank you, Avio. All right. Yes, Shoshana, we're now going to take out a common factor. That's right, on Tetila, we're going to take out a common factor of 2 sine x. Okay, so that means here in the brackets, we've got sine x plus cos x, and that will be equal to 0. So we took out 2 sine x, and this means that either 2 sine x equals 0. Or, please, can we mute? Thank you. Or sine x, thank you, plus cos x equals 0. Please, can we mute? Thank you.
And then she keeps on unmuting herself.
Oh, okay. She obviously doesn't realize that we can hear her.
We're in
Okay.
competition. Let's see.
We are in competition. Okay, so sine x is equal to 0, or on this case, sine x will be equal to negative cos x. The one on the left is a bit easier, but this one on the right-hand side is going to be a bit more difficult. So on the right-hand side, what should I do now? So on the right-hand side, where I've got sine x equals negative cos x, what am I going to do? That's it, Linda. Okay, quite right. I'm going to divide by cos x on both sides because the angles are the same. All right, so you would use co-functions on Tetila when the angles are not the same. Okay, but you can divide Sine x by cos x. You can't do anything else. You can't divide cos x by sine x. It's not an identity, but you are allowed to divide sine x by cos x because it is an identity. So we're going to divide by cos x on both sides. And that will give us tan x equals -1. All right, so now we have to find key angles or reference angles or PAAs. Okay, at my school we call them PAAs. So let's deal with sine x equals 0 first. So our PAA here would be 0 degrees. Okay, because at 0 at the origin, we know our sine x graph goes through the origin. We would consider this 0 over here to be positive. So that means that we need to work in quadrants 1 and 2. So in quadrant 1, we would end up with x is equal to our PAA. So you can either write 0 degrees, or you don't have to actually have to write the 0 degrees, plus k times 360. K is an element of the integers. Or in the second quadrant, it would be x equals 180 minus our PAA plus k times 360. K is an element of the integers. So x would be 180 plus k times 360. K is an element, element of the integers. Okay, so there's our two general solutions. On the right-hand side, we know that tan x will be equal to 1 when x is equal to 45 degrees. Okay, and now we've got to use our negative sign. So tan x will be negative in quadrants 2 and 4. So in quadrant 2, we've got x equals 180 minus our PAA plus k times 180. K is an element of the integers. So that means that x would be equal to 135 plus k times 180. K is an element of the integers. Right. You do not need to do a second general solution in quadrant 4 when you are using k times 180. But your teachers may have taught you to do this using k times 360. So if you use k times 360, you've got to show both solutions. Okay, so your alternative here, and I don't know why we would do that because it would be more writing, but if you want to, you can do this as well. So x would be equal to, remember we are in quadrant 2, so that would be 180 minus x plus k times 360. K is an element of the integers. So, sorry, not x, sorry guys, minus 45. So x would be equal to 135 plus k times 360. K is an element of the integers. And then you would have to do the other quadrant. So the other quadrant in which it's negative would be quadrant 4. So you would say x equals 360 minus 45 plus k times 360. Okay, but this is much longer in the pink. Okay, we wouldn't generally bother with this. So that would be 315 plus k times 360. Okay, so if we do use k times 360, they have to be both general solutions. If you use k times 180, then you only have to write 1. Okay, so that's why your teachers may have shown you that back in grade 11 and then again this year. Okay, so let's have a look. We've got 6 marks. So a mark on that.
Sorry again.
It's okay. That's fine. A mark on those. That's out of 6. I'm sure they would have given us a mark on tan x. That's 3. 4, a mark on our factors. 5, 6. Okay, so using identities, our factors, our tan identity, and then both general solutions, and either that one or both of those. Okay, are there any questions about that? Are there any questions? No? Are we all happy? Okay, all right. So Vio, you're happy. Shasana's happy. Kamchelo, are you all right with that previous question that we did? You are okay, good. All right. Lovely. Okay. All right. Let's quickly do question 5.3. We've only got 7 minutes left. So I'd like to do that one with you and then we can call it a day. All right. So the first thing that they want us to do is they want us to prove the identity. So in 5.3.1, they want us to prove that the left-hand side is equal to 1. Okay. So sine 2x plus 2 sine squared 45 minus x. Oh, yes. Oh, yes. Oh, yes. Okay. All right. So maybe we should do that. Okay. Okay. Yes. Okay. Let's go back and do that. Let's talk about that question. All right. So in this particular question, where they said for which values of k will this minus k equals 0 have one negative and two distinct positive roots. Okay. What they are, first of all, implying by this question is that your cubic function has been shifted. So you know the equation of your cubic function. It was h of x was equal to minus x cubed plus 6x squared. All right. So that is this bit over here, except it has been shifted 1 unit to the right-hand side. Does that make sense to everybody? Because we've got x minus 1 inside brackets. If we take the minus k over to the other side, we would end up with negative x minus 1 cubed plus 6x minus 1. And if we take the k over to the other side, it's going to be equal to positive k. Now, this is a simultaneous solution. Positive k represents a horizontal line. Okay, a horizontal line. So I'm just going to draw a nice long horizontal line that we can move up or down. Okay. They have shifted the graph 1 unit to the right-hand side. That's given by this x minus 1 inside brackets. Okay. So we would now need to consider that the graph has been shifted 1 unit to the right-hand side. How is that going to change? Because at the moment, the graph has got its x and y intercept at the origin. All right, so we know that when we are talking about its x, and we're interested in its y intercept, because to the right-hand side of the y-axis, our roots are positive. To the left, our roots are going to be negative. So we first need to shift that graph to the right-hand side, okay, and work out what our new y-intercept is going to be. So that's what Coco was trying to do in the black over there. She was saying for your y-intercept, x is equal to 0. So our new y-intercept, when we shift the graph 1 unit over to the right-hand side, we're going to sub in 0 over here. Oh, sorry, that's squared. Okay, so that is going to leave us with, that would be -1, so that would end up being +1 and +6. So that would end up being 7, right? So when this graph shifts over 1 unit to the right-hand side, the y-intercept is no longer at 0. It's now going to be at 7, okay? So in other words, your graph is going to, it would end up doing something like that, rather. And then doing that. Does that make sense to everybody? So it's shifted 1 unit to the right. So this new y-intercept over here is going to be at 0 and 7. But this point over here has not been moved up or down. It's just been moved to the right-hand side. So it's been shifted 1 unit to the right. So our local maximum is now going to be at 5 and 32. Does that make sense to everybody? I haven't drawn the pink graph very nicely. Are we all okay with that? So now we've got this line, our line y equals k, right? And they've told us that they want 1 negative root and 2 distinct positive roots, okay? So if our line sits at our turning point, we only have 2 roots, we don't have 3 roots, okay? Here is 1 negative root, and we have 1 positive root. If we move it above the turning point, above our local maximum, we're only going to have 1 root. So like there, it's only got 1 root. So going up is not the right direction. If I bring it down over here, now I've got what I want, a negative root, which is this bit over here. There's your negative root, and 2 distinct positive roots. So positive roots means where the straight line is cutting the cubic function on the positive x-axis or above the positive x-axis. A negative root means that the horizontal line is cutting the cubic function in a place where x is negative. So that would be in the second quadrant. Now, I've got a limit because I can't go above the turning point because then I don't get what I want. So between that turning point and on the x-axis over here, again, now I've got 2 positive roots. Okay, so that's not going to work because I want 1 negative root and 2 distinct positive roots. So I cannot go past the y-intercept because when I get to the y-intercept, my negative root becomes 0. So my line has to hover somewhere between my maximum and my y-intercept for there to be 1 negative root and 2 distinct positive roots. Does that make sense to everybody? Okay, and that's why the value of k has to be bigger than this y over here, which is 7, and smaller than this y over here, which is 32. Okay, does that make sense to everyone? So your roots change sign on the y-axis. Okay, because to the left of the y-axis, your roots are negative. To the right of the y-axis, your roots are positive. That's why the y-intercept is critical to answering this question. Okay, so that's why we had to find out where the y-intercept was.